Good morning. We have discussed types of corrosion in our previous session, that is differential metal corrosion and differential areas corrosion. Now let us see what are the various factors affecting corrosion or rate of corrosion. The various factors affecting rate of corrosion are relative areas of anode and cathode, corrosion product, pH, temperature and conductivity. Let us discuss these one by one. To start with, relative areas of anode and cathode. So as I have discussed in one of our wet corrosion, differentiating between dry corrosion and wet corrosion. So I have seen, so area of cathode, as areas of cathode increases or decreases, rate of corrosion also will vary. Right, that we are going to discuss here. So if the anodic area is small and cathodic area is large, I repeat, if anodic area is small and cathodic area is large. So let us consider this is smaller anodic area, this cathodic area, then rate of corrosion will be very high. Why? Because here the demand of demand of electrons by the larger cathodic area can be met only by smaller anodic area by undergoing oxidation. So here this is anode and this is cathode. So here the electrons, here this cathode needs 100 electrons, right? So from where this electrons comes? This electrons comes from the smaller anode. So this anode liberates electrons. As soon as this anode liberates electrons, this cathode can accommodate, immediately occupy. So again this anode will be prone to liberate more electrons. Again this cathode will accept this electrons because it can accommodate more than 100 electrons. Therefore, as soon as electron is liberated, this cathode will be accepting the electrons. Since it is liberating more and more electrons, so it is undergoing more and more oxidation. So more and more oxidation means more and more corrosion. So therefore, smaller the anodic area, larger the cathodic area, rate of corrosion is higher. So example, so here iron, zinc, etc. So example for this is a tinning process. So coating tin on the surface of iron and steel articles is called as tinning. So in tinning, this type of coating will be given. So next, so larger other case. So larger the anodic area. So this is anodic area is very large. Smaller the cathodic area, rate of corrosion is less. So cathodic area can accommodate only 100 electrons. But since the anodic area is very large, at a time it is giving 1000 electrons. Okay. So as we all know, unless and until the liberated electrons are accepted, anode will not liberate further electrons. So until this capacity of this capacity of cathode is only 100, but it is liberating more than 100, it is liberating 500 to 1000 electrons. So but this cannot accommodate so many electrons over here. So as I told, unless and until the liberated electron is accepted, anode will not liberate further electrons. The liberated electrons only is not accepted. Therefore, the anode will not undergo further oxidation. So further oxidation means it will not undergo further corrosion. Therefore, the rate of corrosion is also less if the larger anodic area and smaller cathodic area. Example, galvanization process. So we prefer galvanization than tinning because galvanization is coating of zinc on the surface of iron and steel articles. We'll discuss this galvanization at later stages. So next, nature of corrosion product. So any reaction will produce a product, isn't it? So even corrosion also produces product. So depending upon the corrosion product, rate of corrosion may increase or decrease. If the corrosion product formed is highly insoluble, porous, okay, and unstable. Insoluble means as soon as it forms, it will ooze out. Okay, it will not be soluble in the aqueous media. Porous means, see, this corrosion product formed and is porous over here. It is pore. So it is formed and through these pores, this metal is continuously in contact with the corrosive media. And it is unstable. It is formed, it will be oozing out. If this is the metal, corrosion product is formed, it is oozing out. In out of these three, if it is highly soluble, porous and unstable, then rate of corrosion is very high. Soluble means it will be soluble in the corrosive media. Okay, porous means through this pores it will be sticking, it will be porous. Through this pores the metal will be continuously will be in contact with the corrosive media. Unstable means it will form, it will ooze out. So metal is continuously exposed to the surrounding corrosive media. Therefore, rate of corrosion is very, very high in such cases. Example, iron, magnesium, zinc, etc. In other way around, if the corrosion product formed is highly insoluble, it will not soluble in the what? The corrosive media. Non-porous. Corrosion product will be formed, it is non-porous. See, this is the metal, corrosion product is formed, it is covered completely. There is no pores, right? Since there is no pores and it is stable, it will be sticking to the surface. Therefore, what will happen? The corrosion product formed, it will act as a barrier between the metal and the surrounding media. Therefore, the rate of corrosion is very, very less. Since the corrosion product formed as insoluble, non-porous and stable, the product acts as a barrier between the metal. See, you cannot see the metal, right? It will act as a barrier between the metal and the surrounding corrosive media. Therefore, rate of corrosion is very, very less. So, example, aluminium, nickel, chromium, tungsten, etc. So, all in case of passive metals. So, this aluminium, nickel are called as passive metals. So, nature itself has given a boon for them from protecting themselves from undergoing corrosion. Okay. So, next we have pH. So, pH, you know what is pH, right? So, 0 to 7. So, H plus ions, negative logarithm of concentration of H plus ion to the base 10 is called as pH. So, if let us consider iron as an example. So, iron undergoes severe corrosion if pH is less than 3 and is more dissolved oxygen is absent. Why? Because hydrogen, you know that zinc displacement reaction occurs. When you take a zinc and if you dip it in acid, what will happen? Metal undergoes dissolution. So here we consider it as corrosion due to complete evolution of oxygen. Okay. So if pH is greater than 10, it will become a basic medium. It will become what? Basic medium. OH minus ions will be present over there. So when Fe at anode, what will happen? Fe2 plus will be produced. Iron undergoes oxidation to form Fe2 plus. So in alkaline medium, rate of corrosion is very, very less. Why? Because so Fe2 plus ions produced will react with the alkaline OH minus ions and forms ferrous hydroxide. So this ferrous hydroxide will cover the anode, okay, and acts as a barrier between the metal and the corrosive media. Therefore, rate of corrosion decreases. Okay, in acid media, rate of corrosion is very, very high. In alkaline or basic media, rate of corrosion is less because the ferrous hydroxide acts as a barrier between the metal and corrosive media. So, in pH is between 3 and 10, oxygen is essential for corrosion. Okay, if pH is between 3 and 10, oxygen, only in presence of oxygen, corrosion will occur. So, let us see what is our next factor. So, temperature. So, rate of corrosion is directly proportional to temperature. So, why? As temperature increases, it means that as temperature increases, corrosion also will increase. Why corrosion increases as temperature? As temperature increases, conductivity of the medium will increase. So, how conductivity and corrosion are related? As conductivity increases, diffusion of what? Metal ions from anode to cathode will increase. That is movement of ions. So at anode what reaction occurs? Oxidation will occur at anode. So if oxidation occurs at anode, what will happen? The electrons will move faster towards the cathode, right? So if electrons are moving faster towards the cathode, at cathode it will undergo reduction reaction. So if electrons are accepted more at the cathode, then anode will be more prone to undergo more and more oxidation. If the anode is undergoing more and more oxidation, then oxidation is termed as what? Corrosion. Okay. As temperature increases, what will happen? Conductivity of the medium will increase. That is, diffusion of electrons from anode to cathode will increase. So because of that, anode will be prone to undergo more oxidation. So more oxidation is termed as more corrosion. Okay. So temperature is directly proportional to corrosion. So therefore, if in some cases where metals are used to undergo some reactions, so moderate temperature is maintained. If temperature increases, what will happen? Corrosion of the equipment may occur. In electroplating, so moderate temperature is maintained. As temperature increases, what will happen? Corrosion may occur. Okay. So our last factor is conductivity. So conductivity is very important. So discussed in our previous factor, temperature, right? So conductivity. So rate of corrosion is greater. Wet corrosion is greater than dry corrosion. So if you take an example of corrosion in normal water and in ocean water. So in normal water or in marine water. In normal water, corrosion occurs. Metal or iron undergoes corrosion. But in ocean water, corrosion is higher. But ocean, why? Because ocean water contains saline. That is, its salinity is higher. It contains salts, right? If salts are more, what is there? Salts means conductivity will be more. So if the conductivity is high, then what is the rate of corrosion is also more. So when you compare the corrosion of metal iron in normal water and in saline water, the metal undergoes severe corrosion in saline water than in normal river water, because electrochemical reactions occur more severely in saline water because the conductivity is more in saline water rather than normal water. Okay, so conductivity species in corrosive medium increases the corrosive rate. What are those conductivity species? That is NaCl. Okay, so these are the various factors which affect the rate of corrosion. Okay, so next we'll discuss how to control corrosion. What are the techniques available to prevent corrosion control in our later discussions. Thank you.